Good morning, students. In our previous lecture, we have talked about open chain structure or acyclic structure or linear structure of glucose. Now today, we will talk about the cyclic structure of glucose. It means two structures are proposed for glucose. One is your acyclic and second one is your cyclic structure. Now, what is the need of cyclic structure? As acyclic structure has proved most of the points related with the structure of glucose, then what is the need of one more structure, that is your cyclic structure? The reason is very simple. According to open structure, there is one CHO group, but still the glucose does not react with 2,4 DNP, 2,4 dinitrophenylhydrazine. It means it is not showing 2,4 DNP test. It is also not forming bisulfite addition product with sodium bisulfite or sodium hydrogen sulfide. Both the reactions proves that in glucose free aldehyde group is not there. Glucose is not responding to 2,4 DNP test and it is not reacting with sodium bisulfite. So absence of these reactions proves that in glucose free aldehyde group is absent. In glucose, it is possible when CHO unit of glucose undergoes reaction with OH unit of the remaining part and gets converted to hemiacetal. You know what a hemiacetal? The organic compounds in which there is presence of alkoxy group and hydroxy group. It's called hemiacetal. So in glucose, formation of hemiacetal is there. If hemiacetal formation takes place, then aldehyde group will not be free. And if it is not free, then it will not show reaction with 2,4 DNP and sodium hydrogen sulfide. Now how hemiacetal formation takes place and how acyclic structure gets converted to cyclic structure. Let us talk about this point. So remember, whenever we talk about cyclic structure of glucose, then carbon number 1 and carbon number 5 are important. Carbon number 1 and carbon number 5 are involved in hemiacetal formation. Now what happens? This is the structure of glucose, D-glucose. Here on carbon number 5, we have H atom attached with OH. And there is CHO unit on carbon number 1. Clear? Now, this hydrogen migrates to oxygen of C double bond O group and gets converted to OH. Migration of H from here creates a bond deficiency of 1 over the oxygen atom. So oxygen forms a new bond with carbon number 1. In this manner, we get the cyclic structure. You can see with this carbon we are having OC linkage with this alkoxy linkage. With this carbon we are having OH unit present. Hydroxy group is there. So here hemiacetal formation is there. So carbon number 1 and carbon number 5 are important whenever we talk about cyclic structure of glucose. Now this structure can be represented in this manner also, where the carbon atoms of the ring are not shown. So how to start? It's very simple. O at the top. Now move clockwise from carbon number 1. The H which are present on left hand side will be drawn above the plane in the cyclic structure. And OH which are, the group which are present on left hand side will be shown above the plane in the ring structure. And the groups which are present on left hand side will be shown down the plane, below the plane in the ring structure. So starting with carbon number 1, there is your carbon number 1, H is there, so H above the plane, OH below the plane. Then second, H above the plane, OH below the plane, H above the plane, OH below the plane. Then number third, OH above the plane and H below the plane. Then carbon number 4, H above the plane, OH below the plane, H above the plane, OH below the plane. And when we talk about carbon number 5, by convention, CH2OH is always shown on upper side, above the plane. So here is your CH2OH and here is your H. So how many atoms are involved in the ring structure? Total 6 atoms are involved in the ring structure. See here, 1, 2, 3, 4, 5, 6. So the ring structure which consists of 6 atoms. I am not saying carbon atoms, 6 atoms. Here O is also counted in 6 atoms. So there is 1 O atom and 5 carbon atom. This carbon is not included in the chain. So whenever a ring structure consists of 6 atoms, then the ring is called pyranose ring. The ring is called pyranose ring. So this structure is called glucopyranose. Now, if we change the orientation of CHO group on carbon number 1, in case first C double bond O is located on right hand side, if it is represented on left hand side, then OH unit H from carbon number 5 will migrate to oxygen of C double bond O group, carbon number 1. So OH unit will be facing towards left hand side and here OH is there on right hand side. So there will be a minute change in the orientation of OH and H in the space. In case number 1, H is above the plane, OH is below the plane, while in case number 2, OH is above the plane and H is below the plane. This is also glucopyranose, but the structures differs in the orientation of H and OH. So these are related as isomers, and here these are called anomers. The isomers of glucose are called anomers, and carbon number 1, where we are having different orientation for H and OH, is called anomeric carbon. The first form, where OH group is present below the plane, is called alpha glucose, and second form where OH group is present above the plane is called beta glucose. So first form is your alpha glucose form, second one is your beta glucose form. Both are glucopyranose because both contains 6 atoms in the ring. So this is about the cyclic structure of glucose. That's all from my side in the structure of glucose. We have covered acyclic structure as well as cyclic structure of glucose. Thank you and have a nice day.